5 o'clock. So let's start with today's webinar. So welcome everyone. I'm happy that we have found the time today for this webinar. Let me first introduce myself. My name is Jan Krupička, and I'm delivery manager and IT consultant in Krone Consulting. I have 15 years experience in software delivery, mainly in quality assurance, and last year also have experience with AI relevant projects. Krone Consulting, we are a company based in Bratislava in Slovakia, and we are currently established markets in Slovakia, Germany, Austria, and also in Denmark. We are a consulting company focusing on AI transformations, also sovereignty audits and quality assurance. I'm also co-author of MainNext, which is our unique methodology, which is suitable for implementing AI to software development lifecycle with heavy focus on business value and quick prototyping. That's my short introduction, and let's focus on how this meeting will be held. Okay, forgot for the slides. Never mind. Okay, some house rules for this meeting. So your microphones are muted during this webinar, but you can interact with me either by surveys or through questions in Google. I will show you later how to where you can find it, because not so many users are familiar with Google user interface. This webinar will take 30 minutes, so we will end plus minus at 17:35, and then we will have time for questions. So don't hesitate, ask questions. You can start questions from the start. In case we will not manage to go through all the questions, I will answer the questions later, either directly through LinkedIn, or I will send you an email. So we will finish at 17:50, because I really want to respect your time and don't want to make this webinar longer. Okay, so now just a quick showcase where you can find the part regarding the questions and regarding the polls that we will hold, and we can slowly start. Okay, so just on these 9 dots down there on the right bottom corner, and then depending on your language, you will find polls or questions. So let's begin. When I was thinking about this topic for this webinar, I must say I was heavily inspired by my LinkedIn feedback feed, and also my Facebook. All those miraculous eight prompts for Hollywood grade video. Just copy and use, and you will have it. Or I have made production grade analysis for new market in five minutes. Actually, I was a bit skeptical about this, and I still am, but there is something about it. There are a few people who who I'm watching that they really succeeded with these prompts. But I was asking why, because all what we see usually are few well-written prompts, and we don't see what's behind the curtain. We don't see the failed attempts. We don't see which data are taken to make the final goal. We don't see the examples. We don't see the expected outputs or inputs. That's all hidden from us. And all these things are the context that we will be talking about. Because that's, I would say, probably the most critical thing for applications using AI or for agentic workflows. But first, let's move from my Facebook feed and move to the real enterprise business. Because what is critical for business when using large language models and agentic workflows and AI workflows? Well, for all the businesses, not all, but nearly for all, the key is to have the right data, and also to have the right answer when you are doing some action. What we are seeing today, we are moving from simple experiments on the enterprise grade, from POCs to really autonomous systems, which have one thing common, and that's more and more actions are done and managed by AI or agents. And this is something that is really important, because in case you don't have a human in the loop, you have only one shot to get it right. And you can imagine what can happen when you are using AI and it makes mistake. And it can make mistake because large language models, they are probabilistic. You don't get 100% correct answer for everything. What is also important, when you are using AI and large language models, but I'm using it as a synonym right now, but it's not exact. When you are using it, then usually your data that you are using, your internal corporate data, they are the models were not trained for this. These are your private data. The AI don't have access to them from the internet, and AI will always answer to you, even if it's wrong answer. But it will stand here and say, okay, this is the correct answer, even if you tell it that this answer is wrong. Then it will say, okay, I had a mistake, but it will be really stubborn in this. You can imagine the impact for example, for healthcare or banking or legal cases, when if you will use agentic workflows or AI systems that are not 100% precise in the execution and make mistake, this can have a life devastating outcome. That's what high precision is critical for business. What is also important, even if you are not in this, let's say, critical field, and the AI don't take actions that are so critical, every small error counts. It's like snowball effect. if you make error on the start and don't have a human that will fix this error, then this will snowball. It will probably iterate several times, and it costs more and more and more. And you can have either better result, or it will cost you more. And that's not what you really want. Why I'm talking about this? Because context engineering is somehow partially solving this issue. That's the first time that I'm talking about context engineering in this webinar. If I will ask all the people that are here about what is context engineering, and maybe I will ask. So maybe let's start the poll now, the first one on this slide, and we will keep it active until later. I'm just curious. The first answer is if you are aware what is context engineering, if you can explain it. Don't worry, there are pre-selected answers. So just select your answer and vote, and we will see what are the results later on. Okay, let's continue. So, what is context engineering? If you will ask any model that is on the market, we will get probably several answers. But I really like the definition from Anthropic. Context engineering refers to the set of strategies for creating and maintaining the optimal set of tokens information during large language models inference, including all the other information that may land there outside of the prompts. This is really nice definition, because it's not about finding the best solution from the point of prompt. It's not only about the prompt. It's about all the things that the large language model is taking to the context and use it in the most efficient way. So you want to make it cheap, fast, and correct, ideally. But actually, there are several problems with even in the field of context engineering. First, I will talk about context window, because context itself, it's a limited resource, and we must treat it like a limited resource. Every AI model has some context window size, and even if you give all the necessary information to perform some actions, some activities, if you are using it will probably lost its focus. You go. I will give you an example. Let's say you want to analyze Lord of the Rings fantasy trilogy, and these are quite nice books. I recommend to read it, not only to watch the film. But if you try to analyze the and make a summary of these three books, and you will use, for example, Claude Sonnet or Claude Opus, well, you are screwed, because what you will do? Okay, I'm going to Claude. Okay, here is the Lord of the Rings book. Now give me a summary, perfect, and it will not work, because actually context window is measured and this limitation is quite strict. You cannot get over it. It will lose the focus. It will lose some information, that is critical for making the final answer. For example, The Lord of the Rings, it's slightly about 500,000 words trilogy, and it's like 700,000 tokens. So if you have context window of 1 million, then you're probably fine. So Gemini could do this, or GPT High. But if you will take, for example, Harry Potter series, then even these two models with large window will not make it cut, because Harry Potter has something like 1.4 million tokens. So you can imagine. So this is the reason why raw force is not working, because it's not working in case your context window is too big, or the context that you are putting to context window is too big. What is also important, the context window is not working, let's say, same through all the distribution. There is non-phenomenon known as contextual, which says that with increasing context in context window, the quality of the answers is decreasing. The sweet spot is somewhere between 60-70%. Actually, it has been really proved by some studies by needle in the haystack. That is really interesting method. I'm recommending to find it, how this method works. But that's also important to take into account when you are talking about context engineering. Your resources are, your context window is limited. It's not this distribute. You cannot use it to the full for the optimal results, and you must come with some, let's say, strategies and things that you need to solve before you do that. Okay. Now let's talk about context itself. I'm talking about context engineering, but I have not mentioned the context. First, to understand it, let's shortly explain how the large language models works and how the agents and agentic workflows works. Usually, LLM is not if we are talking about let's say chat applications, like Claude or simple Gemini or GPTs. You put some text. This text, your prompt, is transformed to tokens. Then it will find the most relevant sequence of tokens for your answer for your task. So it's token ins, tokens out. The same is also for agent. The difference is the agent could be started, for example, from some input. For example, you receive an email, and it will start, for example, workflow, or something similar like this. The agent works similarly. It gets the tasks, it gets this task, and it's trying to solve this issue on its own using a large language model in this process, and also the tools. It's doing it iteratively until it finds the solution that will be pushed forward. So every context in this case is made from several things. First is this system prompt. Every large language model has some system prompt by default. You can manage it. You can write it, and it's quite important for this topic. I will talk about this later on. Then you have some user message. This everything. This also, that's something that you write. You maybe write more messages when you are iterating through your solution to get the best result during your session. Then you have assistant messages. These are the answers that the large language model gives you back. In case of agent, for example, if this agent is also text-based with GUI and not hidden, that's the final result that you will get. And now the most interesting thing, it's resources. Why it's so important, these resources? I told at the beginning that large language models were trained on the data from internet. So when we are talking about implementations in the enterprises or even in your smaller companies, it don't have access to your Wikipedias, your manuals, your code base. At least it shouldn't have. If it has access to this, then you have quite a big security issue, and maybe you should solve it somehow. But these resources are private and are only yours. You are owner of this, and you can nobody else has access to this. Every company has its own set. It's very big topic from the point that this is the hardest thing to solve from the point of context window. Because imagine that you have, for example, code base that you want to analyze. That's, let's say, depending on the application, of course, but it's it could be several millions of lines of code, which cannot be solved by just putting into large language model. There definitely, this will not work because it will not fit to this context window. So there are different strategies how to solve this. I will talk about it later on. Then we have also tools, especially if you have this agentic workflow or agent that manages other agents. They usually use a lot of tools. You need to have describe this tool, how to use this tool, or what to expect, and so on. And you have also tool calls, and all these things are going to this context window, to this like a context. And that's an issue from the point of view that, for example, user messages, assistant messages, and tool calls, that's something that is with every iteration, it's additive. You are adding more and more and more and more, and it will not fit to this memory. So what are the strategies? How to solve this problem? First, one of the first strategies is to adapt the system prompt design, because it's often neglected, but the system prompt gives the large language model basic instructions how to work, what should be outputs, what is the persona, even what is the environment, what are the tools that you have to solve the problem. This is very important, because good system prompt increases rapidly the efficiency of how to resolve the task that the AI have. Also, what is important, you have to be on spot from the point how to write the system prompt, because in case your system prompt is too is not very precise, then it will not cut. Also, if you write system program in style if then and you make nearly a code grade system prompt, this will also not work very well. You must find the sweet spot in the middle, because it's important from the point of efficiency. Second point is the tool architecture. I've mentioned that the agents have tools that you can use. It could be, for example, some Python script very often, or call some API or something like that that could use to work well. You need to have a good and precise description of what is the goal of the tool, because overlapping these tools is not working. You don't want to put more and more and more. You must be precise, like a surgeon. What is also good to have some schema of how the input and output should look like, because that's something that is easily to read from the point of machine, from the point of LLM, and how to manage it. The next, and that's probably the biggest part of how to work with context, because this resources, that's intelligent retrieval. You can either use RAG, that's retrieval augmented generation, or model context protocol, which is more modern. It depends. Both have its strengths and weaknesses, but actually this is how you will work with your resources. It will tell, for example, to chunk it to smaller pieces and give only the relevant pieces to the context. Or in case of model context protocol, it could give you let's say iteratively more and more information. If I will use, for example, the book, the Lord of the Rings, you can tell it, okay, you have all these three books for you, and now work with it, and it will find the books, and you can work with tools behind MCP to analyze this book, not only using AI, but also using other methods like heuristic or maybe another call to LLM to summarize it and give a summarization or something like that. That's also possible. But these two tools or methods, it's not tools, methods, it's more better, like RAG and MCP, that's how you manage your resources. And the last pillar, that's the long horizon strategy. Because even if you will use all these three techniques and strategies to reduce the context for the most complex tasks, you will still get over, especially for the models which don't have so big context window. There are several techniques how to solve this. For example, compaction and summarization. Compaction, just go through your context and removes, let's say, saves somewhere to the external file information that's on the context, and then delete the unnecessary information from the context, like assistant messages or tool calls or something like that. The things that are not necessary for now to get to the results, because the large language model either have already the results or don't need it anymore for now, at least the goals, because it has only the part that's relevant. Or you can have summarizations. So you use another LLM when you are getting to the, let's say, critical point of a context window that will summarize this context window and then delete the rest. And you are working only with the summarization of the context window. Yeah, it's valid technique, and it's often used. You don't even know that it's used several times. For example, in Cursor or Cloud Code. Then you have techniques like using memory. You are storing some critical information to external files and then using the files when you need it. You are just pointing to it that, hey, model, you will find the answers here, and it will get only the answers when it's needed. And the last one, it's composition. And then that is technique when you are using, let's say, agent with sub-agent, which every sub-agent is specialized for some types of tasks, and the main agent is responsible for orchestration. What is really cool about this part is that every agent has own context window, so it somehow crumbles this to more manageable pieces from the point of context window. Okay, looking at the time, and let's get to the end. So what is the main reason? What is the biggest benefit of context engineering? It protects the quality, because with the use of context engineering, you are not losing quality over time. And that's important for the long shot, especially for big companies where you want the stability for longer periods of times. Also, it enhances reliability, that you will get answers that are relevant and more reliable, grounded to the sources that you have in the disclosure. Also, this enables true agentic solutions, because with information flows to get the information just in time when you need it, it's something that's very often used by the agentic systems. Also, I've mentioned it, but keeping your resources still at your file systems, not putting your resources, your wikis, and so on to the internet. That's definitely good for your security. And the last thing, that's the cost efficiency. As was mentioned in the definition by Anthropic, it's strategic to make these things happen with the minimal amount of tokens, and less tokens, less money you need to pay. Okay, that was my presentation. Maybe let's take a look to the first poll for the results. And okay, how familiar are you with context engineering? And we have quite interesting results, because it's split it evenly. So we have people that are already working with context engineering. That's great. And we have people that we have two people that already heard about this and have some idea. But we have also people that never heard about this topic, and it's new for them. Okay, that's perfect. So let's start the second poll. That will be interesting for me. If you have learned something new uh, from this webinar, and let's move directly to the questions. Okay, first question. Inference is or is not the same for all context window? Well, that's a really good question, because in case you are using one workflow, the inference is the same. It's like I would say starting new chat. That's the most easiest way how to explain it. If you are starting, everyone knows ChatGPT or Gemini. If you are starting new chat, that's new inference. But in case of, for example, agentic workflows, when you have agent that it's managing several agents, every agent has its own inference and own context window, but it's getting the results up. Okay, I hope I have answered this question. And second question, what about short, long memory and conversation history? Shouldn't be considered as context? In your opinion, what is your recommendation when you see obvious mistake in a conversation history made by a large language model? Well, conversation history is part of depend on what you meant by conversation history. In case of conversation history that you meant that what was your conversation with this uh, uh, large language model, and what is the answer, then yes, this is definitely part of context window. But if you think about conversation history that is usually on the left side, that's keeping your history of conversations, then this is not part of the context window. And second part of the question, what is your recommendation when you see obvious mistake in conversation history made by large language model? Well, that's a tricky question because it can be solved by several ways. First, you can adjust your system prompt in case if you want to, let's say, have some one shots. Adding also some good examples and expected outcomes. That's one point of view. Second, if we are talking about, for example, making the mistake despite the fact that it use your resources, your data, it's more about, let's say, improving either the prompt, how you ask, or maybe also look to your data if also there is not some incorrect answer. Usually, when you are using things like MCP or RAG to get your answers grounded, you will get the correct answer. But it really depends on the situation and on the data. Okay, another question. If understood correctly, the context engineering is basically to ask correct questions, to ask the questions correctly based on the topic, of course. Have engineering-oriented critical thinking about the answers and try to discuss with agent large language model as short and accurate as possible. Well, not only if we are talking about you as a user, when you are using your own solution, it's about setting up usually the system prompt and have a good prompt engineering. But this will not be enough in case you are using some kind of resources, because that's a big part of it. And maybe critical, especially for the big enterprises, because in case you have for example this code base that you need to analyze, then you need to start thinking about how to maybe implement some rack solution or MCP solution, or use a different tool that will help you analyze this. So definitely it's not only about correct questions and not only asking questions correctly. Okay, another question. To error in context. Point is, if destroy context completely and start over, or try to fix it and keep current context. Well, sometimes it's better to start over error. This is quite useful, for example, in case of if you are, for example, white coding. Sometimes thinking a new, let's say, point of view will help you to solve this issue, but that's not the point of the context engineering, because if we are talking about agentic systems, they will try to fix this error on themselves. So they will get to the point, hopefully. If not, then you will definitely need to stop them and start again. But probably adjust some things in your system. Okay, and I'm looking on the questions, and I don't see any new questions here. I hope I have answered all the questions. Okay, so we are done and nearly just in time. So thank you for attention. Before I say farewell, just quick information. You can buy the Mainnex Manifesto, the book that I have also written. You can connect me on LinkedIn, and this is especially interesting for people in Denmark, you can meet me on Testing United, the conference that we are organizing this year in November in Denmark. So that's also a possibility how to connect with me. Don't hesitate to connect with me, ask questions. I will definitely answer you. So thank you for attention and goodbye. Have a nice evening.